Good morning. Today we'll talk a little bit about geometry. Well, as we know, geometry is a mathematical system, and geometry, in order to build the concept of geometry, we start with some unidentified terms, and then we define geometrical things, which we call definitions. Then we accept few facts without proving them, without going through a logical proof. We accept few facts. They are called axioms, and based on undefined terms, some definitions and some axioms, then we build geometric argument, geometric logic, and we prove things regarding geometric shapes. They are called theorems. Well, for example, we say point. Point is just an intuitive idea. We really cannot define what a point means. When we do a dot, we think that's a point. Well, if I have a smaller pen, probably I'll have a smaller dot showing a point, and it is really difficult to define what exactly a point is. It's just the intuition that we draw a dot and we say it's a point. So point is undefined things. Similarly, by line, when we say line, are we thinking of this or are we thinking of this? Things become little confusing. So, well, by line, when we say line, in general, we think of the straight line, and again the question might come, what do we mean by straight? So we accept the concept of line without defining it. Similarly, planes. Planes, what do we mean by planes? Well, planes are in general the flat surface. The flat surfaces, they are called plane. The whiteboard is a plane, a piece of paper is a plane, a wall of a room is a plane, the floor of the room is plane, even the roof of the room is plane. So we intuitively understand what plane means. We don't try to define plane at this point. Okay, so then once we have the plane, once we accept the concept of line and concept of plane without defining them, we can use this concept to define something called half plane. Half planes are defined by two parts of a plane partitioned by a line. So if this is the plane, if this is my plane, if I divide this plane into two parts, let's say by this is half plane, this is one half plane, and this is another half plane. So with the help of these three undefined quantities, we are able to define a fourth geometric quantity, namely half planes. So this is how the geometry will develop. Furthermore, we can define line segment. So, well, half plane, we already said half plane, we have a plane, we partition this plane into two parts. I might have partition like this. This will be one half plane, this will be another half plane. Now we can think of line segment. Since we already, we already accepted what line is. Line segment is a segment of a line with endpoints. Starting at A, ending at B, the line that starts at one point and ends at another point is called a line segment. And we can define half lines and half planes. So for example, let's say this is a point. I can define half lines. Half line means a line is starting from this point without any end point. It's going in that direction forever. And sometimes this half line, this is half line and sometimes half lines are called half rays also. Okay, then once we have the concept of line segment, concept of line, we have another geometrical notion, another geometrical quantity that we can define, and that geometrical quantity is said to be angle. So angle is when two lines intersect, they form an angle. That's how angle is defined. This is the angle, and this point, let's say this angle A, let me write the name of this line segment to be AB, and this line segment is AC. I have two line segment AB and AC. They are meeting at a point. If two line segment meets at a point, they form an angle, and this point, wherever the two line segment meets, in this case, this A is called the vertex. A is the vertex, AC and BC are the sides. These are the sides of this angle. So this is a side, this is another side, and that's a vertex. Now angles are measured in so many different ways, using so many different units. One of the units of measuring angle is called degrees, and degrees, minutes, second, the degrees, minutes and seconds are used to measure the angle. Well, in fact, this 60 seconds will be equal to 1 minutes, and 60 minutes will give us 1 degree. This is how this three quantity, degree, minutes and second, they are related. And one of the geometrical instrument that we use to measure the angle, to find the measure of an angle, it's called protractor. Looks like this. This refers to 0 degree, and we have 10 degree, we have 20 degree, we have 30 degree, we have 90 degree, we have 70 degree, we have 130 degree, we have 150 degree, and we have 180 degree also. And another geometrical instrument that is very useful in constructing angles and so many other things is called compass, and it looks like this. We put this end not containing the pencil at one place, and the compass will run like this, and it will be, we can use compass to create angles, to construct angles like this. Okay, and now once we are talking about angle, based on their size or based on their measurement, the angles are classified as a right angle, acute angle, obtuse angle, and straight angle. Right angle means an angle which is 90 degree. If this angle is 90 degree, we call it right angle. Acute angle means any angle whose measure is less than 90. This angle now, the measure is less than 90. 90 is this much. Well, if the angle between two lines is 90 degrees, sometimes we say the lines are perpendicular. Here the two lines are perpendicular, angle between them is 90. If the angle between two lines is less than 90, then this angle is called acute angle. Well, we can have this situation where the angle between the two lines is more than 90, then we say it's obtuse angle. And we can have a situation, this is a line and another line is this, so the angle between the two line is this much, which is 180 degree. If angle between two line is 180 degree, then they are called straight, that angle is called straight angle. This is straight angle. Well, now if two line intersects like this, this is one line, this is another line. If two line intersects, you can see there are four angles altogether formed. One angle here, another angle here, third angle here, and the fourth angle here. This angle and this angle, they are called vertical angles, and similarly this angle and this angle, they are also called vertical angles. By vertical angles we mean the pair of angles. These two together, they are called vertical angles, and these two together, they are called vertical angles. And you should realize this the vertical angles has to be always equal. This angle and this angle will be always equal. Similarly, this angle and this angle will be always equal as well. So if somebody gives us this problem, let's say this is 60 degrees, how much is this? Then our answer should be this is also 60 degree, because this is 60 degree, these two are vertical, the measure of this angle and the measure of this angle has to be the same. Okay, now we have a concept of perpendicular and parallel lines. If we have two lines, they intersect at an angle of 90 degree. If this is the situation, let's say this AB is a line, line segment or line whatever you want to call it, CD is another line, they intersect and make an angle of 90 degree. This is an example of perpendicular lines. This is perpendicular. In this situation, these two lines are called perpendicular lines, and we can have two lines. We can have two lines, let's say AB and another line CD, let's say, and regardless of how long we extend these two lines in either direction, they're going to never meet. If we have two lines which will never meet, even we extend the line all the way up to infinity, then this kind of two lines, they are called parallel lines. Parallel lines means the lines they do not meet, or we may say the angle between the two lines is 0 degree. They are not meeting, they are not forming any angle. There is no angle between AB and CD, so they are called parallel lines. Well, when we have parallel lines, let's say this is AB and another line is CD. If these two are parallel lines, if we have a third line intersecting both the parallel lines AB and CD, let's say this XY is the third line that intersects AB and CD both. In this case, XY, the line XY is called transversal. When a transversal intersects the parallel lines, you can see so many angles are formed. One angle here, another angle here, another angle here, 4 angles here, and similarly 4 angles here. There are some of these angles are related, and there are some very nice relationship between those angles. Okay, a relation among this angle, sometimes we call alternate interior angle. Alternate interior angle is like this. These two are the parallel lines. Let's say this is our transversal. So by alternate interior angle, we mean this and this, or this and this. So these two are called alternate interior, these two are called alternate interior, and the nice thing is alternate interior angles are always equal. So if somebody tells me this is 30 degree, I can tell this is 30 degree as well, because they are alternate interior. Alternate interior angle has to be equal. Okay, well, now we talked about the concept of line, concept of angle, concept of parallel and perpendicular line. Now we have another concept, curves. So curves are, if we join 2 points and we join 2 points without using any line segment, we don't have any line. This geometric shape is sometimes it's called curves in geometry. And once we have curves, you know, if we think of curves, or it could be any, it could be even a straight line. Let's say we have a circle. Let's think of a circle. If we think of a circle, and if we think of any 2 points in the circle and try joining them by a straight line, this straight line will be entirely inside the circle. Think of this is a circle. Now let's think of another closed curve. This is a closed curve, and if you think of 2 points in it and think of joining this, the line joining the 2 points inside the closed curve is completely within it. If that happens, we say they are closed set. So by closed set, we say closed sets that refers to closed plane, not open. This is open plane. A closed plane such that lines joining any 2 points, such that joining any 2 points in it is completely inside it. So this is an example of convex set. This is an example of convex set. We might think of a triangle. Take any 2 point, the line joining the 2 point will be inside the triangle. All these 3 here, they are example of convex. They are example of convex set. Well, and in planes, we might have concave sets as well. Let me, well, that's convex, so let me draw a concave set over here. Let's say I have a geometric shape looking something like this. If I take this point and I take this point, I am taking this point and this point, and if I join it, you can see this portion of the line. This is outside of the shape. If this happens, if that happens, if we join 2 points inside the closed geometric shape, and the line joining the 2 point, a portion of the line joining the 2 point is outside of the shape. In this case, this portion is outside of the shape, so we call it, this is called concave. Convex means every line joining any 2 point inside the shape, inside the region, has to be inside, completely inside it. Well, we already talked about circle. Circle is defined to be the curve so that every point on it is at equal distance from the center. This is the center. This is the center of the circle, and every point on the circle, the distance of any point, we choose any point on the circle on this curve, then the distance from the center will be the same. If this point is 5 cm away from the center, this point will be also 5 cm away from the center. So we already know what the center is, and the distance of any point on the circle from the center, this is called the radius. This is called the radius. Now, if we have a circle, let's say this is a circle and this is the center of the circle. If we join any 2 points on the circle, this point, a point here and another point here, if we join any 2 points in the circle, let's say this is point A, this is point B, this AB is a chord. A chord of the circle is AB. By chord, we mean join two points on the circle. The largest chord of the circle that goes from the center, let's say this is XY. XY is also a chord of the circle, but that is a special chord. It goes from the center. This kind of chord, XY, they are called diameter. You can see half of the diameter is radius, another half is also radius. So diameter has to be twice as long as the radius. Now, for a circle, we can have a lines that will just touch the circle at a point. This line, let's say PQ, it is just meeting the circle at a single point. It is not intersecting the circle more than once. The chords will intersect the circle at 2 points. See, meet the circle at A and B, X and Y, but this line PQ is meeting the circle only at a point. Let's say the point is R. This PQ is called tangent. This is called tangent at the point R. So this is tangent to the circle at the point R. Okay. The next concept that comes with the circle is what we call circumference. Circumference is nothing more than length of the boundary, or may say the length of the curve. If we cut the circle here somewhere at a point, make it a long line and measure its length, that's called the circumference. Circumference is length of the curve. Now, when we think of circle, we are thinking in fact of the boundary. If we think of a geometric shape which includes the boundary, which is a circle, and the interior, this everything inside, this is called disc. I probably have a coin in my pocket, that's what I am trying to pick. A quarter is a disc. The boundary is a circle, and when we think of quarter, we are not thinking only of the boundary, we are thinking of the interior also. So disc means a circle, a filled circle, let's say, a filled and its interior. Now the next concept in geometry is polygons. Polygons are nothing more than plane region whose, I should say, closed plane regions, they have to be closed, plane region whose boundaries are straight lines, straight line segments. So, for example, a triangle is a polygon because it's a closed and the boundaries are straight lines. Similarly, square is also a polygon because it's closed region and the boundary of the square, they are straight line segments. And if we use 5 straight lines to construct a closed region, that's called pentagon. If we use 6 line segment to construct a region, that is called hexagon. Heptagon, octagon is 8 sides, nonagon is 9 sides, decagon is 10 sides, and we can have as many sides as we want to construct a closed region. The sides has to be straight line, they are called polygons. Okay. Now, we will talk about some property of angles in polygons. One of the thing in geometry we are interested in knowing what will be the sum of all interior angles of the polygon, and it's easy to find. Sum of all interior angles of a polygon is n minus 2 times 180 degree, where n refers to number of sides. So if we are thinking of pentagon, n is 3. If we are thinking of triangle, if we are thinking of triangle, n is 3. If we are thinking of quadrilateral or squares, n is 4. If we are thinking of pentagon, n is 5. So if the question is find the sum of interior angles in a pentagon, so sum of interior angles, interior means this, we 1, 2, 3, 4, 5. Let's say this is our pentagon. This is called interior angle, this is called interior angle, this is third interior angle, this is fourth interior, and this is fifth interior angle. We want to know if we add them up, how much will be the total. The total of all the interior angle for pentagon is, because n is 5, this is 5 minus 2, n minus 2 times 180. So n minus 2 is 3 times 180, so it will be 540 degrees. If we add all the angles of interior angles of a pentagon, then we get 540. Similarly, if we want to calculate sum of all interior angles of an octagon, octagon means n equal to 8. So sum of interior angles will be equal to 8 minus 2, n minus 2, 8 minus 2 times 180 degree. So n minus 2 is 6 times 180 degree, 6 times 180, 108. Let me use calculator. 6 times 180 equals to 1080. So this is 1080 degree. Sum of all the angles of a octagon. Octagon will be 1, 2, 3, 4, 5, 6, 7, 8. This could be an octagon. So 1, 2, 3, 4, 5, 6, 7, 8. Sum of these angles will be 180. Okay. Now, congruence. Another concept that comes in geometry is the concept of congruence. By congruence, we means exactly same looking geometric object. Two geometric objects are called congruent if they are exactly the same, or if one can be put on the top of another so that they will coincide. So this geometric shape, whatever it might be, is congruent to this, because if I cut this one and paste over this one, they will coincide, they exactly overlap. Those kind of geometric, two geometric figures, they are called congruent figures. Sometimes we write this symbol to represent the congruency. We cannot call them equal, but you know they are congruent, they are same. That's all congruent means. Well, and here is another example of two congruents, quadrilateral. Well, we have to think of how to place it. Maybe LM should go in the GW, and we can place this over here by rotating it, so that these two geometric shapes will overlap. They are called congruent geometric shapes. Well, now we talked about polygon, a special class of polygon. They are called regular polygons. By regular polygons, we mean the polygons whose angles are congruent and the sides are also congruent. That means if we have a polygon whose all sides are equal and whose all angles are equal, then we say it's a regular polygon. Equilateral triangle are regular polygon. Squares are regular polygon. This is regular pentagon, regular hexagon. The only thing is this angle will be the same as this angle, will be the same as this angle, will be the same as this angle, and will have this angle will be the same. If we just say pentagon, those angles might be different. But when we say regular pentagon, the interior angles has to be the same, and even the length of the sides has to be the same. So because this is a regular heptagon, this side will be the same as this side, and this side, and this side, this side, this side, all the sides will be of equal length. If one of them is 1 inch, every side is 1 inch. Well, now one of the things that comes in geometry is how to draw regular polygon. In order to draw a regular polygon, we draw a line segment and mark a vertex. The first thing, we draw a line segment and mark one point on the line segment and call it one of the vertex. And we will measure of the interior angle. We know that each interior angle for a regular polygon has to be n minus 2 times 180 divided by n. We did few problems where we did the calculation of the sum of the interior angle. Now each of the interior angle, we are not thinking of the sum, each of the interior angle has to be n minus 2 times 180 divided by n. So once we find the vertex, we measure of that angle, mark of the side of the equal length. So we have to, because we are thinking of regular polygon, sides has to be of equal length, and measure of second angle of n minus 2 times 180 over n, and I should say continue the process. Number 5 is continue the process. Let's see how we will construct a regular pentagon. So in order to construct the regular pentagon or regular polygon, the first thing is to find out measure of the angle. The interior angle. The interior angle for pentagon, because the formula is n minus 2 times 180, it will be 5 minus 2, n is 5, divided by n is 5, n minus 2 divided by n times 180. So let's do this calculation first. So this will be 5 minus 2, 3 over 5 times 180 degree. I think we will get 108 degree if we do this calculation. Let me see if I am correct. 3 times 180 divided by 5, yeah, that will be 108 degree. So in order to construct a regular pentagon, this is what we will do. We draw a line segment. Let's say this is a vertex. So we select a vertex. Vertex means this is one of the corner. Now from this line segment, let's say we want this much to be the length of the pentagon, A to B to be the length of the pentagon. Well, when we are constructing, we will be given how big the sides has to be. If it is 2 centimeter, we will make AB 2 centimeter. If it is 5 centimeter, we will use a scale and make AB 5 centimeter. Now what we have to do is, using our protector, we have to construct, put the protector, the center of the protector here, so that this angle is 108 degree. So we want 108 degree as an angle. So this is the side that makes 108 degree over here. We construct that side. Now since we want the regular polygon, we already have specified the length. Let's say A to B is whatever centimeter, whatever is the length of AB, we cut the same length on this line. Let's name it, let's say AC. What I am saying is AB and AC has to be the same length. Now once we figure out this C, again we have to measure another 108 degree at C. So we will go this way, making 108 degree. Now from C, again we will measure the length from A to B or A to C and find a point D, and continue this process. This will be 108, and cut again this DE. Let's say DE has to be the same as AB, and this is how we're going to get the regular pentagon. one way, there is an alternative way of constructing a regular pentagon. Alternative way is to use a circle. So, well, if we want to use alternative way, we have to remember this fact. The central angle, we will be using circle. So, I will explain what do we mean by central angle in a second, but the central angle has to be 360 degree by the number of sides, 360 by n. So, we will be drawing a circle with a compass and measure an angle of 360 degree over n at the center, mark n equal segment with the compass and connect the points. These are the 4 things we will be doing. I will explain what do I mean by this in the case of regular pentagon. So, for the first thing I need to know is the central angle, and for pentagon, since n is 5, central angle is 360 divided by 5. I do not know how much is that. So, 360, come on, 360 divided by 5 is 72. So, in this, for pentagon we need a central angle of 72 degree. Once I know how much central angle we need, this process of constructing is simpler than the previous one. We construct a circle using a compass. So, this is, you put a compass here, that is how we construct using a compass, and I am assuming you guys know how to construct a circle using a compass. So, this circle is constructed using a compass, and well, draw a line, use your protractor to get an angle of, in this case, 72 degree in here. This is 72 degree, let us say. Using compass, we can find this point, so that this angle will be 72 degree. Now, using compass, we use compass to measure from here to here. Using your compass, this is what we need to do. This is, let us say this is our compass. So, we will find how wide the compass has to be in order to cover this region. Then we will start with the same measure in the compass, and we start from here and cut this. So, second, third, 4, 5. So, these are our 5 points. Now, what we do to, in order to construct the pentagon, is we connect them 1, 2, 3, 4, 5. The pentagon is now constructed. Here the pentagon is constructed with the help of a circle. So, we know 2 different ways of constructing a regular polygon. Well, another concept that comes in geometry and in fact in art, is called tessellation. By tessellation, we mean any arrangement in which non-overlapping figures are placed together to entirely cover a region. So, we have a plane region, we want to use geometric figures to cover that region, we do not want to have any overlap. That is called tessellation. So, this is one example of tessellation. You see this, this plane region is covered by this kind of geometric figure. And you see one of them is here, another is here, another is here, another is here, another is here. They are using different color anyway. So, we are covering the entire space with the help of those geometric figures. It is called tessellation. Well, you see in this I am using polygon 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So, this is a polygon with 11 sides. However, you will realize these figures, they are polygons with 11 sides, but they are not regular. They don't have the equal length, neither the equal length nor the equal angles. So, they are not regular polygon. So, among regular polygon, if we want to use regular polygon to cover a plane region without leaving any gap, the only regular polygon that can be used to tessellate or cover a plane region, they are either equilateral triangles, or these are the equilateral triangles, see these are, each of them are triangles, and we can cover the plane region using those equilateral triangles, or the squares, or we might use the regular hexagons. Only 3 regular polygons that can be used to cover a plane region entirely without leaving any gap is either a square or an equilateral triangle or regular hexagons. Well, so we talked about various concepts in geometry, starting from the point all the way to the congruent polygons, regular polygons, and how to use them to tessellate or to cover a plane region. If you have any question, let me know. Thank you for watching.